All right, so what we'll spend time today is we're going to, as we reviewed just linear equations and solving them, what we're going to do is instead of talking about an equation that looks linear, what we're going to talk about is an inequality. So today we're going to focus on graphing something like this, and then we're going to spend time shading above or below. And then in the coming day, Monday probably, we'll graph something that looks like this and shade above or below that. So let's focus our attention and recall graphing linear equations or linear inequalities. Do you remember what kinds of points we used in the olden days? If I had simply this, the greater than symbol, and let's refresh, so please write this in, whenever your variable is greater. So that's what we got to consider. Our variable has to be greater. In this case, it's going to be y is greater because y is the dependent variable. So in the olden days, when it was just talking about graphing it on a single line, what we said was this. If we had a greater than situation, we would do what kind of point? Would it be open or closed? We would do open point, and if greater, what would we do? We'd shade it in which direction? We'd shade it to the right, which is in the positive, towards the positive, or getting bigger. All right, however, when we are graphing in this situation, one option is this. Well, I could plot a whole bunch of open points, but look how much lots of work that could be. So instead of saying plotting open points, what we're going to say is we're going to dash the line. The line. The line is dashed. And if it were greater than, where would you think you would shade? Would you shade above the line in this direction or below the line in this direction? Great. This one's going to be shade above the line. Now, the one time that it's not going to be above is if you graph a vertical line. If you graph a vertical line, then that'll be shade to the right. Okay. All right, so continuing on. These ones over here are both dealing with solid lines because of the equal sign. Solid lines. And then this one here would be shade below, and this one greater than is shade above. So we're going to do a hybrid. Effectively, we're learning nothing new. All we're doing is integrating two concepts you've already looked at. So let's practice after we look at some vocabulary. So a linear inequality is essentially a linear function that has greater than, less than. So it's a linear function with less than, greater than, less than or equal to, or greater than or equal to. Technically, it's true that not equals to is an inequality, but we're not talking about, so we're not talking about this symbol here, not equals to. Yes, that is true, it's not equal, but we're not talking about that one. All right, so each point in the region that we shade, everywhere we shade is actually a solution. So instead of just having a solution on a line, like we've done before, we have a region of solutions. And we'll look at practical applications either today or Monday, actually Monday. The solutions of the inequality are what? They are infinite. So there's an infinite number. And they satisfy the inequality. Another thing is that it's a point. You will always have an x comma a y. So three things. You have an infinite number of solutions. It's got to work. It's got to satisfy the inequality when you plug it back in. And it's going to be a point, some x value and some y value. It's hard to see the shade because of the printing, but in this case, since y is greater than, I'm shading in this direction. So that means in this case, it's all the points that are above the line. Well, in this other problem, it's less than, y is less than, so I'm shading below. So it's all the points on the line and under the line. So the solid means included on the line. So let's take a moment here to graph this inequality. Well, this is absolutely no different than remembering what we do with our slope and y-intercept, we know that b is -1, and we know that my slope is 3, which means 3 over 1, which means go up 3, right 1. All right, so besides having our where to begin and our slope, we also know something else. What kind of line is this going to be? Is it going to be a solid or a dashed line?
It's solid.
It will be a solid line. Why do we know that? Because of the equal to part. And since y is by itself, y is greater than, we actually know which way to shade already. We are going to shade above the line, shade above the line. So we're going to treat this exactly like we would a linear equation, except when we connect the dots. In this case, I'm paying attention. I will connect them solidly. So let me make a graph here. I need my x and y axis. Axes, excuse me. It tells me where to begin. I'm going to begin at -0. Then I'm going to go up 3, 1, 2, 3, and right 1, and plot this point.
How do you set negative?
And since this is a solid graph, a solid line, I can go ahead and just connect the dots solidly with a straight edge as best as possible. Now the next part we have, all right, now what? We have to determine which way to shade. So according to this, greater than, we're going to shade above. So this is how you can shade. One way to shade it is like this. Just spend a whole bunch of time, scratch, 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 scratch. Now, I would suggest not doing that. Number one, the reason for that is because I have transparency, right? I can lighten my line and you probably can't. So I suggest rather doing this. And instead of drawing all like that, what you do is just draw a few lines going in that direction. So something like this. Just this thing and this thing, this thing. You don't actually have to do the arrows. If you just want to say a couple lines like that, that's fine too. The benefit of this is that since we have content behind the shade, we want to be able to access that. So -1, +1, that is one of my solutions. So how do we know we're right? Well, let's check. What is one point over here? That's a very nice point that we can check.
-1, +1.
-1, +1 works, but even better, 0, 0. Let's test 0, 0. So I'm going to plug in 0, 0. So 0 is greater than or equal to 3 times 0 minus 1. And then we get 0 is greater than or equal to -1. And that's true. Yay! So we know that we shaded in the right direction. If we tested anything over here, it would be false. And that's something we could also test. Expecting false, I could put 2, 0 in. In putting 2, 0 in, I get 6 minus 1 is 5, and 0 is greater than 5 is false. So all this material will give me false over here. Everything over here will give me true. Now let's turn the page and look at the very top. And notice that this is in standard form. And so the first thing we sometimes will say, wait a tick, shouldn't we change this to y-intercept? And the answer is, actually, standard form is very nice. Why? Because it helps me find my axes. I can find my x-axis, my x-intercept, and I can find my y-intercept very quickly. Remember how to find the x-intercept? This is all you have to do. And now solve that. 6, x is, and I'll do equal to instead. So we'll do equal to here, equal to 12, and when you divide, you get x equals 2. How do I get the y-intercept? Well, it's the exact same thing. First you do this. And now we solve that puppy. In other words, I substitute a 0 in, and when you substitute a 0 in, you get your other axis intercept. So that'll give me 1.5. And we say to ourselves, wait, that's a decimal. Hey, that's okay. All you have to do is plot a point that's in between two lines. So notice where I'm going to be. On the x-axis, I'm going to be at 2, and at the y-axis, I'm going to be at 1.5. So if I throw down a few scale here, at the x-axis, I'm at 2. At the y-axis, I'm 1.5. So notice I'm between the two lines. Which way am I going to shade? Excuse me. Am I going to do a solid or dashed line? Solid line there. Great. We see it's solid because of the equal to symbol. And now when we think about shading, which way do we shade? My instinct says that it's probably going to shade above because of that greater than symbol. And there's two ways to check that. Number one, I can solve for y, get it by itself, and then use the shortcut. But the other way is just to check this point. This point right here, 0, 0, should work to shade that way or should not work to shade the other way. So if I check a 0, 0, this is what I get. When you plug in 0, 0, you get 0 is greater than or equal to 12, which is false. And since that's false, I'm going to shade away from that. So you flee the falseness. The last thing we want to examine is how this applies. Well, most of the time in life, we do not have to spend exactly a certain amount of money. But in this case, we're going to spend no more than $24. So that's ultimately what a budget is. We're going to spend less than or equal to $24. So suppose your budget allows you to spend this much money for decorations for a party. Streamer rolls cost $2 a roll, and tablecloths cost $6 each. Use the intercepts to graph the inequality that represents the situation. Find 3 possible combinations of streamers and tablecloths you can buy. So the cost of the streamers, what's that going to be? Well, the cost of the streamers is going to be $2 times however many that I buy. So that'll give me the total cost of the streamers. Plus, we're going to add the total cost of the tablecloths. Now, they cost $6 each, and however many of those that I buy. And let's actually be consistent. It does ask us to use T for the number of tablecloths, so I'll change that, and the number S for the other. And, of course, our total can be 24, so it's got to be less than or equal to 24. Now, it asks us to use the intercepts. So, in other words, if I drop this one out entirely, what do I get? Well, I get 2 streamers is going to be $24. $2 times streamers is going to be $24. And what's that give me? That means if I only bought streamers, I could buy 12. So that's going to be on the x-axis here. Now, if I only bought tablecloths, then I see how many I can buy. T is going to be 4. I can buy exactly 4 tablecloths on this. So when I connect the dots, is going to be this line right here. Now, which way do I shade? Well, it does say less than or equal to, but I could always test that. But as I shade this region right here, we see a couple options I have. Notice what will work. I could buy 2 streamers and 2 tablecloths. I can buy 4 streamers and 1 tablecloth. I can buy 6 streamers and 1 tablecloth. So there are not quite an infinite number. We are limited because we can't buy partial rolls and we can't buy partial. So we're just going to actually focusing on just where everything intersects there.